Sonia, Geeta, I think we should start and introduce the speaker so that.
Should we start?
Yeah.
What's Patricia do?
Hey. Anyway, Venkatesh has to start it, so please.
Patricia, we can start, right?
Yes.
Okay, so Sonia, go ahead.
Good evening to all of you and welcome for the keynote session on design thinking and data science for social justice and diversifying the field of computing. We have with us Patricia, and over to you, Venkatesh, to introduce her.
Hi, welcome back, everyone. It's a privilege and pleasure to welcome Patricia Ordóñez, who is an associate professor of computer science at the University of Puerto Rico, Rio Piedras, though she currently joins from Maryland. Her research interests span, a lot of trending topics, including applying visual analytics, data mining, machine learning, visualization, and human-computer interaction to medicine and assistive technologies. One of our goals is to help medical providers create better diagnosis and treatment plans by learning from the data of previous patients with similar conditions. As one of her initiatives in the area, she founded the first symposium on health informatics for Latin America and Caribbean. She has followed a non-traditional path to earning her PhD in computer science, and that's actually what is more relevant for this community, and I believe she will say more about that in her talk. She was scared of computer science during her undergraduate studies, so she moved to math, and she taught math in high school for many years, and then she was again motivated, among others, by her own students to go back to computer science. She did her PhD in computer science from University of Maryland at Baltimore. She likes to mentor and develop mentoring communities in K-12 undergraduate and graduate educational settings. She also creates assistive technologies for programming and communication to help ensure computing is accessible to all. She has recently began a term as the co-chair of ACM's Inclusion and Diversity Council. So over to Patricia.
Thank you very much, Venkatesh. I am here to talk to you about design thinking and data science for social justice and diversifying the field of computer science. And I'm going to tell you a story about what happened in Puerto Rico, and then tell you a story about how I got into it, and then tell you a story about why it's so important to diversify the field of computer science. So this is Hurricane Maria. It landed in September 20th, September 17th, September 20th of 2017. And you'll see that as it's coming to Puerto Rico, you'll see that the circle at the beginning, it's very defined, and then it kind of starts breaking out. That's when it went from category 5 to category 4. And what you're seeing this is satellite, and it's basically an estimation of waterfall. And so this right here is another satellite vision, and you'll see that now what happened when it hit and why it only goes to that point is that electricity system throughout all of Puerto Rico fell. So what you see here now, this is showing you actually the waterfall. A few seconds later, you'll see that the circle is actually more defined, and so the eye of the storm is more defined, that circle. And so many people on the island believe it went back to category 4, 5, but it's only been category 4 because when you have to have 155 miles per hour for a sustained minute for it to be considered a category 5. And at the moment that the winds the electricity went out, these were the measurements that we had throughout the island. But everyone on the island is convinced that this was actually category 5, and they are doing analysis. They have to look at the structural buildings to try and figure out what it is. And these statistics and this information actually came from consulting with NOAA, which is the National Oceanic Atmospheric Administration of Puerto Rico. I'm going to show you a little bit of a video so you can see the damage. This was actually done by NOAA the day after the hurricane. And I need you to see all this so that you can understand a little bit of the story. So here, this is the flat part of Puerto Rico. This is basically a little bit north of where the hurricane hit. And if you notice, this is like the agricultural land, and you'll see that immediately after, it's basically like a mud land. And yes, it made it very hard to travel. Here again, this is now one where the hurricane exited. This is in the mountains, and this is basically a river between the mountains, and you'll see the difference and how it overflooded. And you'll see this little bridge in the middle. That little bridge, take a look at that. I'm going to show you that bridge. That was the main method of communication of transportation between the big cities and this particular section of Puerto Rico. This is another part in the center of the island called Villalba. And this is also in the mountains. Many people don't know Puerto Rico in its center has a lot of mountains. And it's actually difficult terrain to go through. It was very, very windy, beautiful mountains. And so what I wanted to show you here is an estimation of, an estimation showing the landslides that were caused by Hurricane Maria. And so you'll see that the dark red is basically the region that had the most. It's more than 25 per square kilometer. And the rest of it, the light red is less than 25. And basically the white and the gray have not been measured. But the thing here that is really concerning, this is Utuado, and this is the region I'm going to be looking at, so you can understand a little bit more of what kind of devastation happened in these areas. And I just show you this because this is a project for children. Since I know a lot of you are teachers, this is a project for children to kind of cope with this natural disaster. And so I leave it there for you since many of you are educators. So let me just show you what those landslides look like. And typically these landslides happen when you have from the hills, you have a river coming down, which made a lot of water come down. And then there's an intersection with another road. And so that caused the taking out of the bottom road. And this is what it looked like, made it impassable. So several regions in Puerto Rico were, first of all, without water, second, without electricity, and third, without a means of getting out. This is the one that I was trying to show you in the middle of the island in Utuado, and it shows you here the bridge. This is the bridge that had no pass. Now, after this devastation, what happened is that the governor actually stated there were only 16 deaths, and I think you can tell from the devastation that would not be the case. And so as a result of those reports, very little aid came to Puerto Rico, and the urgency of what was happening in Puerto Rico was not handled. And so this is what they started doing. Basically, they started using design thinking, figuring out how to help each other. And it's one of the most incredible things I've ever seen or even heard of. So in this case, there was no way to get to that community. They had no water, no food. So what the communities did, they basically, one climbed up on a tree on the opposite side. They created a pulley to take this cart up to the top of the tree, and it went down over to the river. And then from there, anything that they wanted to take out would come back. And basically this was the way that it was possible. And if you'll notice, like, look at this is just people in impoverished areas helping themselves. This part right here, it says Campamento Los Olvidados. It's basically the camp, the camp of the forgotten. And that's what it was. These are American citizens, many people don't realize this, they pay taxes. And this is the response from the government. And so now let me go a little bit now to the science. I wanted to, just so we're all on the same page, explain what a data science is so that we can, this story will take form and give you an idea of what we're talking about. So data science is basically the intersection of math, computer science, and some domain to solve complex problems. And basically through that collaboration, is where you can acquire knowledge from these large amounts of data that are being collected in just about everything we do, from shopping, from whatever you're searching on the internet. I mean, there's just tons of data. And so how can we use that, the Twitter space, how can we use that data to infer knowledge? And so that's what data science is dedicated to. Now, classical researchers had this kind of like, you knew a little bit, you look at this T-shaped classical researcher, where they basically, had a big focus on something, and they were kind of like pretty good at all the other things. What happens with the modern researchers that it's more like pie-shaped now, especially in data science, because not only do you have to have a domain specialty, but you also have to have some basic knowledge of statistics and computing, and this part, so that this part of statistics and computing is so people can communicate. And so I was around before data science became a term, and I worked on, I would say multidisciplinary groups versus interdisciplinary groups. And I would say the difference between multidisciplinary collaboration is that everybody did their things by themselves. And it was more like, hey, you need to provide this, you need to do this, you need to do that. Whereas interdisciplinary actually collaboration looks at, trying to understand each other so that we can get the most out of each other's expertise to solve a complex problem. And it requires a change in mindset. Now, one of the things that I just want to say, like a data science pretty much works like any other kind of sciences, in that you here on the right, you can see that you create a hypothesis. The difference is that here, instead of gathering, doing experiments to gather information, you have to actually like search for the data, and it's usually large amounts of data. So there's this part of data gathering and then data wrangling, because most of the time this data isn't really well formatted, it's unstructured. And so you have to find a way to give it some structure so that you can do the next point, which is what you typically do in science. You do some exploration of the data. In data science, you do a little bit more creative visualization than the, just graphs and things like that. So you actually try to do a little bit, there's a whole community doing work on visualization and different kinds of visualization and interactive visualization. And then you do the data modeling and machine learning to basically implement something to test your hypothesis and then validate it. And typically what happens in data science is that you only go back and forth on these last two steps. So the design thinking that I just talked about, and that happened a lot in Puerto Rico, was like people would get together and realize, hey, this community is in trouble, which is this empathize problem. Then they define, okay, how, we got to get water and food to them. How can we do this? And then this community would brainstorm to try and figure out what to do it. And then the big focus is on defining the problem and how to solve that problem, and then actually going back and forth in these steps, and then building some sort of prototype, testing it quickly, and then if it doesn't work, go back. So there's a lot more, if you notice, there's a lot more of lines within design thinking, because you can go back and forth to everything. And sometimes you even go back to okay, do we have to think of the user in another way? So what I try to tell people is that you really need to be doing more design thinking to do really great data science and do it more quickly. And I think the story I'm going to tell you about what happened after Hurricane Maria will show that. So most of the stuff happened. I'm really telling the story that was given by Rafael Irizarry of the Data Fiber Institute. He came to our university. He's a former alumni, and he's also a a professor of biostatistics at Harvard. And so he basically gave a talk on the importance of good data and scientific communication and talked about this story. And it's really a story about him and this other professor. They're both at the Chan Institute, Harvard Institute for Health, I think it's called, and for public health. And so they both teach there. And so Dr. Bucky, she basically went to Dr. Irizarry and said, hey, I have these collaborations in Puerto Rico. I have not been able to reach them. They tell me that these numbers of the official death counts are not true. And so she basically says, hey, can we try and create something so that we can find out what the real numbers are? And so then they start seeing that people start publishing about, numbers. So first, on November 8th, New York Times publishes an article based on funeral home data that they've gathered. Then November 20th, CNN comes up with basically an estimate of what they believe it is, which is about 499, which is really different from the 16 that are happening there. And then, of course, Penn State is another on November 21st, they came up with another one. So this number keeps growing, and it's significantly different from what is given by the government. This whole story, if you want to look at it, I've given you the statistics. I mean, the blog, he wrote a blog about it. And so all this, he came and gave the talk and then wrote a blog. And the blog actually has really good links to all the articles. It's phenomenal if you want to look at this on your own. But anyway, so what he did was, he basically took the Penn State data and he scraped it, and he basically compared it to data that he could get for the previous years. And so that was just 2 months of data. It was September and October, and it's very evident here, like looking at all the previous data, right? So notice how you can see that there's a range that is the normal range and even abnormal range, and what we have in September and October is much greater. And so what he found, this 0 right here, this is above the monthly average in Puerto Rico. So this is like going 500 above the monthly average in September. And this is going like, close to that. So he realizes, okay, there's something here. Nevertheless, the registry demographer says there's no 2017 data. And so they decide they're going to design a survey. And they asked the Penn State author to see if they can share the data, but nothing. Then December 7th, there's kind of similar to like what ProPublica is in the US. This is like the Centro de Periodismo Investigativo. It publishes its own estimate of 1,000. So basically what Dr. Irizarry does, he basically starts getting on Twitter to ask for data because he just doesn't understand how come he's not getting the data. And then December 8th, a New York Times article comes out and they have the data, daily data. So it's evident that they're not being given some data, and that also raises flags. And then December 13th, the Public Security Secretary basically says that the estimates are just wrong. And they basically changed, but they did change the official date to the death count to 55. Anyway, getting that data, and by the way, this is one of the things that I do with my class is have them go through this process of scraping the data and plotting this in my data science class. When they come through this, what ends up happening is that you see automatically that there's something really wrong, right? There's missing data. Well, it turns out during this time, there were basically 2 people at the morgue that were doing autopsies to be able to declare whether they, to be able to count up. And so what was happening is that the without electricity, they did have a morgue, but basically having 2 people and the number of bodies just gathering up, there was no way to get this information. A girlfriend of mine, her husband died during this period. It took her over a year to get the official cause of death. So a lot of this is missing data because of the fact that everything's being backed up. So anyway, going here, on January 25th, they respond to Dr. Becky and say they're not authorized to provide the 2017 mortality data. And so it's just really obvious that they're not getting the data, but other people are. So Penn State then asked the Puerto Rico government to make it public on February 1st. The government says they've hired somebody to estimate the death toll, George Washington University. However, there's other estimates that are being published from data from the Puerto Rico Institute of Statistics. So finally, on the 28th, the Puerto Rico Institute of Statistics sends them the data that they have. And at this point, then again, they do the same kind of estimates. And now they're looking at the number of deaths to see how many had actually, died in all these different years. And even if you took all those, you have the different years, right? It's still obvious also that there's missing data and that this is definitely really above what the normal is. So there's a lot more than what is being stated. So then they took to designing the estimate toll. How can they design, something in data science, a survey or something that could estimate the death count? So what they basically did was they took a stratified survey. So stratified meaning that they went to all the different communities, very wealthy. They have like 7 stratuses in Puerto Rico. So they went to all the 7 stratuses and in different regions, and they basically did a survey about 3,100, I think 120 some homes to find out how many people had died in these homes. And so they, did random estimates, and then they looked at the percentage of deaths in those communities and multiplied it times a population estimate to get kind of an estimate of what they wanted. Now that was the design, but of course, something like this requires some sort of interdisciplinary collaboration. And they had a lot of trouble getting that because it was like, and finally, getting something like it was complicated because it's like, okay, the university's talking, it was just too much bureaucracy. But finally, he found a professor, Dominguez Marquez, from the University of Carlos Albizu in Viejo San Juan, who they were already doing interviews, because this is basically the largest producer of PhDs in psychology and actually of PhDs in Puerto Rico. And they were basically on the foot trying to find out what was the mental health of people. And so what they did was add a few questions to that survey and went to the towns that they went to. And so they designed that. So imagine doing all this in the matter of months. Like it really took this incredible collaboration. So after scraping the data, then what they did was create a model that took into consideration not just the data, but let's look at the increase in rate of mortality, but let's also look at seasonal effects. Like now we're going from summer to winter, and then also look into the population estimate. Although I will say that in Puerto Rico, winter is not winter in the rest of the world. It's a beautiful winter. It's a hot 80-degree winter, so it's not your typical winter, but for the purposes of people understanding summer and winter, we'll say winter, summer versus winter. And also take a look at the population estimate. And then what they want to do is compare the prediction from the rate of mortality to the past years. And so with that, what they did, on May 29th, the official death toll for Hurricane Maria was raised to the 24th, yet that same day they published in the New England Journal of Medicine an estimate about 5,000, less than 5,000, but close. And after that, now CNN interviews the governor of Puerto Rico and asks him, hey, why aren't you making this data public? And he basically said, well, there'll be hell to pay if people don't do that. And that same day, they made the data public. So I just want to show this. This would not have been possible if there wasn't this incredible pressure from media and this incredible collaboration between, scientists in Boston with scientists in Puerto Rico. And actually, when you look at the paper, you'll see there's a lot more, interdisciplinary, right? You needed people in psychology, you need people in statistics, you needed people in epidemiology. So there was so many different collaborations that happened as a result of this. And that's the way you can do these quickly and and also so they get attention. We could have done in Puerto Rico these estimates, but it wouldn't have gotten the attention that having a team from Harvard do it. And so I say this too because he's one of our graduates, right? The importance of having, high quality research training in public education is really important. And then, of course, getting K through 12 into those classes is really important. So this is one of the examples of where I say, you got to build some relationship with your alumni. Really important to have that because they can influence things in the future, which so many of the alumni from Puerto Rico are doing that right now with everything that's happening in Puerto Rico. There's even an organization called Ciencia Puerto Rico that is really focused on doing that. The ones that have had to leave for science, they come back and influence. And then there's and then again, K through 12, we've got to get everybody so that we can get the best and the brightest into the public education system. And so this is what makes me so passionate. Here, I wanted to show you how when you actually plot it on one axis, it's very clear that, there were many more deaths. This is the death rate, and it was just really, really clear how great it was in Hurricane Maria, and then how long it lasted. Like basically this high effect lasted all the way until April, March, July, between April and July of the following year of 2018. So again, I put these, you can get all this information on that blog that I told you. The other thing that he did that was really important, I'd say this for data science, is reproducibility. He made everything public. All the statistics that he did, I'm referring to Dr. Sarri, and by making that public, he made it so that people could reproduce the survey. And this is also something that I do with my class, so that they can see the importance of reproducibility. And I'd say this also, that one of the things that you need to do to get students more engaged in computing is to give them culturally relevant data and data science for social justice. I think I've even though there may be issues with the way I teach sometimes because I'm a little bit too, I think people, I have trouble organizing, but the fact is I can get them hooked by giving them culturally relevant data and things like this, that is data science for social justice, right? Like getting them hooked on seeing the value of this. Like that's the important thing, that they connect to that and that they want to, no matter who's teaching them, they want to succeed. All right, so here's the actual publication. I just wanted to show you because you have people from public health, you have psychology PhDs, you have, PhDs and, masters in public health, lawyers. This was necessary for this publication, first of all, to have been done so quickly, and also to get the coverage that it did, because then it was relevant and it was reliable. And so again, I mentioned that, no matter where you are, somehow you need to be connected to these top universities. And I'd say this a lot because many of the top universities don't understand, like they kind of look at it when you're at the satellite, they look at it as like, oh, we just want to take the best, but it's more than taking the best. You really need a collaboration to raise the entire country up, because otherwise, you're taking valuable assets, human assets from those communities. And if you can't give it back to them, then you're really just, you're not doing enough. And so I think I've done a lot in talking to people at these high level institutions to mention the importance of giving back to the places where your students are coming from. So look at this number. This is what happened after this. They basically put this in front of, this is the Capitol. People came and started putting shoes to try and get up to that 4,645. The marches had this, and there are even more places. People put it on their bodies. Like this number really moved this basically the people in Puerto Rico were so upset with everything, the lack of help, the lack of government protection. And so all this led to all these things. It started to be the black flag because people were dying and there was no recognition for it and there was no help and aid coming. And this is a territory of the United States where these are US citizens that pay taxes, right? They pay for FEMA. So basically a third of the population of Puerto Rico came out to protest the governor because a chat came out of the governor where basically he was mocking the number of deaths that was going up. So he well knew that the number was inaccurate, but he kept saying the official number. And eventually this happened for about 2 weeks. It was one of the most incredible, peaceful protests. I've never seen it. It was like all levels of society were protesting, and they finally managed to get him out of office. Unfortunately, something goes on because this is where the hope of becoming this state kind of, I think, hurts Puerto Rico in many ways because they voted the same government, even though they got rid of the governor, they voted the same government into power for the second term. And so now they're facing electrical issues that make it really hard for people. I have had a hard time connecting with my collaborators in Puerto Rico. And so it's just yeah, it's an issue in Puerto Rico that racial equity, systemic racism continues. To go on with what they did. So once the new data was available, he did a statistical analysis and posted it on June 8th. And he got more to the 3,000 number. And then August 27th, they said an estimate of about 3,000, which is the actual number. And then they did something really cool, which is compare it to other hurricanes, because there was always this thing of, oh, well, Puerto Rico wasn't hit as hard as Texas or as hard as Florida. And so they created a model that takes into consideration the same things that they had for the other hurricanes. And then they compared the mortality rate of Hurricane Maria to the other storms. And we're able to prove this, but this did not get as much publicity. And in fact, even my students, when they come, they still think that the number of people who died was 4,625. And no matter how hard they try, or 45, no matter how hard they tried to say, hey, realize this comes from a small survey, there's a big, standard of deviation. And even though they posted that the standard deviation could be 700 to all the way, I don't remember what the top number was. So they posted that whole deviation, and that did not get published. Just the number got published. So here, though, looking at the percent in change of mortality, they're able to show how actually in Puerto Rico, a lot of these immediately after affect there's it is a much more substantial, because there's a percent change in the mortality of the region more than before. So, but again, it did not get as much publicity. He even did a really good thing here where he actually plotted the deaths with a standard of deviation so that he could show how the standard like how certain he was the number of deaths after Hurricane Maria, and he looked at Katrina and George. And so it was, and Hugo, to compare to other storms in other places. And so this is basically trying to show, hey, yes, Maria was much more severe in Puerto Rico than in other places. And, causes, we're not inferring causing, but at least showing that there was a much greater excess number of deaths. All right, so then this finally does get published, even though, June, this is the problem with publication, right? But the wonderful thing with being able to publish your results beforehand. So this was June 8th that it was published, but it only made it to Puerto Rico March 6th, and still did not get as much attention. So lessons learned. Basically, tough problems require both design thinking and data science. They require mutually beneficial inter-university collaborations, and you have to have reputable universities working with you. And I wouldn't even say, I think all universities are reputable. I mean, reputable in the sense that they have a high reputation. for research. So we really have to bridge the digital and data divide among universities and communities. And so that would require education in data science, design thinking, and computer science as soon as possible and as early as possible. There's like, even if you don't have electricity, there are ways, there's CS Unplugged from New Zealand that they're doing a phenomenal job with, not because they're an island like us. And, there are communication issues and internet issues, but you could still do it. The computational thinking, right? The statistical thinking that can happen in the classroom before you even get to the actual, computing. So data science is important again for everyone. I think I've stated that because especially now, there's so much fake news, and it's, now what has happened in the United States, I see it going to other countries. And so I'm connected to many people in Latin America because of the work that I've done there, and seeing the same issues happening in Latin America is really troubling. And I really see that the only way that we can actually fight this is by giving everyone an education in data science. And making it inclusive and making it accessible for everyone, and making it accessible in the sense that they can understand it, making it real, making it culturally relevant. So you are the key. So I'm telling you all this because I want to tell you a little bit of my story. I actually was a teacher. So and I share this with you because I think if I was at your place, I would have this. This is what happened when I gave a keynote at Texas. I actually had it, and these girls, they'd never seen a female data scientist. They literally tracked me down and tried to get a picture of me. So I really think that one of the things is data science attracts women because it is interdisciplinary. And I think, so one of the things that they do, that physically we are different, is apparently there's this connection in the back of our heads to our brains in the back. I can't remember what it's called, but it's thinner in men than women. And so I think that one of the things that we're really good at is like, it's hard for us to just do not hard for us, but we can do it. But it's just that we like making more connections with people, and we like doing more, more interdisciplinary stuff. And so data science really, really is appealing to women. But you need to make it an inclusive atmosphere. So this is me. I was actually a math whiz when I was in high school and elementary school. But I was a Latina and I didn't speak English until I was about 5 when I started going to kindergarten. And there, what happened was that I finished, my parents are Colombian. And so we went to a summer in Colombia, and I took my math book and I finished the book before anybody. That was about 2nd grade. But because my English wasn't good, they actually didn't advance me to the next level. And so I sat in math class, just doing my own things, dreaming about math, thinking about things of what I did. And because I think in part I was really good at math because the English was always a challenge for me, right? So as a result of that, my parents put me into private schools. Now, this is the 2nd private school I went. The first private school was a wonderful school. It was welcoming. It was very diverse. And it basically raised all my confidence. I came to this school, which was, you can see it's a very, in a way, homogeneous. And, we were required to wear uniforms, and it was just a very different environment for me. It was something I didn't feel comfortable in, although I was voted friendliest, right? But I felt like an outsider. And as a result of that, I think people didn't see my potential, So I left my college feeling like I wasn't that good at things. And what I did win was the field hockey award while I was there. So I did do sports and I did do musical stuff. I loved doing a lot of things. And so I did go on to play college because it had basically my confidence in athletics was greater than my confidence in academics. And what ended up happening is I became a math and a Spanish teacher, because I actually went from Started electrical engineering, very intimidated because I did computer science. So I had actually programming in high school, which was really odd for girls at that age. Yet when I went into the room, it was like five girls and like 100 men. Very, very intimidating, very, very, yeah, you feel spotlighted. And even when I went back 15 years later, it was the same thing. I remember once I walked into a classroom and there were two women in the classroom and we both wore a skirt. And the guys were like, did you guys plan that? There's just, people are watching you and you feel that, right? So it's very, very, it's uncomfortable. And so I actually left on engineering, went to math major. And actually from math, I was doing math and pre-med, thinking I might do medicine. I worked at a hospital, no medicine. So that was enough. And so then I basically went to doing languages because I'd always loved languages. And that was one of my goals, to speak many languages. And so I left and I became a Spanish math and I could have done science, but I didn't have the confidence, believe it or not, to do that. And so here I am when I first started field hockey on the right at the first school, because one of the things as a Latina, girls aren't supposed to do sports. But at my private school, they forced me to do sports. So, and it turns out I was good at it. And so I went on to play college. And I went on to coach at the high school too. So like all these things, and teaching was really great. But it turns out that I had no pedagogical experience, like nothing teaching. I did a lot of tutoring, but I didn't know how to teach. So my success didn't go there. So what I did, there's a long period there that I can talk about, but I'm going to skip it. 16 years later, after having gone back to being in technology, doing technical support and feeling really isolated there again, I decided, okay, I have to go back to school because my thirst for doing computer science is there, right? But as you see, most of my colleagues were men, and there were very few women. I know that I'm a female magnet because once, my lab ended up having a whole bunch of females, the lab that I worked with. And so I think this is what we need. We need more women, right? If we start having more women, well, it'll attract more women. Makes sense. Anyway, if you want to hear the story, there's a link there and you can read about it. It's an interesting story. So eventually that took me, thanks to graduate school, there was a program there that supported women and minorities in science. And thanks to that program, I got funding. I didn't even know I had to do funding. I didn't realize I had to get a PhD. This is how disconnected I was. And I had no idea about research. And so all this, like going to these professional and personal development, I learned what I needed to do and I did it. And so that's how I ended up at the University of Puerto Rico in the College of Natural Sciences. And this here is one of my favorite pictures because it's the research I do is in assistive technology. Actually, unfortunately, my biomedical, I had to pick between leaving Puerto Rico and picking up another field because when I got to Puerto Rico, it was mostly paper and my research requires electronic health records. So, because I was doing clinical informatics. So I decided to move over to assistive technology. And here's a professor in the middle, Torsten, and he basically does research in assistive technology. And we collaborated, and these are my students that helped me collaborate with him and helped me collaborate with other people. And so this whole field of assistive technology has just, it really attracted more students than the biomedical because it required, at my university, it required Java, and we didn't teach Java. And so I trained somebody and then they'd leave because we didn't have a graduate program. And so it was, yeah, so in the end, I started doing assistive technology. So one of the things that I tell you here is that, first of all, I hope that inspires many of you to go back to school, because I went back to school at 38. And I really think it's never too late. You just, obviously I had to pick between doing broader impact or research. And I went with the broader impact because when I taught my school, my university, most of them didn't know what computer science was. And that just broke my heart because I realized I needed to do something about K through 12. And so I started focusing on K through 12 and creating education opportunities in data science for my students. Now, what do I wish I had known before entering college? I wish I'd known, because I think these are the things that would have helped me succeed. And I tell you as K through 12 instructors that there's basically three categories of things that you need to focus on. One is social science for the minorities, so they understand what is going on with them. So social science, talk to them about imposter syndrome, stereotype threat, unconscious bias, what preparatory privilege is, and I'll get to what that is a little bit, and then give them culturally relevant curriculum so that they can engage and feel like computing is for them. Show them the power of computing. The next thing that you need to do is tell them about how to fund their education, right? So many people, especially if they're from low incomes, they need to find out how to do fellowships and scholarships. So learning how to do that in high school would be very valuable. Teach them about the significance of confidence and communication in science, like how, you know, you have to build that, and communication is really important in science. The importance of getting mentees and mentors and advocates. Also telling them it's okay to cry, because sometimes it is overwhelming, and that's good, right? It's good that you care about something so much that it makes you cry. It's not good if it's always the time. You have to teach them coping mechanisms. And then, of course, talk to them about the importance of networking. These are all things that you don't get taught in K through 12, but should be part of there. It should be part of it. Another part here, down here, is, you know, I learned all this as a teacher. I'd never heard the term self-efficacy until I was in grad school, which is really like, it's basically how you can build confidence that you can do a task. And it just never even occurred to me that I could do that. And then I heard about the growth mindset and praise, and realized that I could change my mindset. I always thought I had, you know, I really had a fixed mindset, and that makes a difference. The one in the middle, never believe a prediction unless it empowers you, this is Sean Stevenson. And he basically was predicted to, people with disabilities have served as such an inspiration for me. He was predicted to die by the age of 9, and he lived till 34 and was an incredible person. And I learned about him through TED Talks. So I tell my students, do TED Talks. That's a good procrastination mechanism, because it'll inspire you to think differently. And then the other thing is the Dunning-Kruger effect in computing. So this is something where novices kind of like believe they're much more experts, and they come off as much more experts. Part, I think, is because maybe insecurities. But for a woman, when you see that, you feel like, oh my gosh, I'm never going to be as good as these people, without realizing that they're not really that good. And it wasn't until I started teaching that I realized that. And that's what made me want to come back to school, because I was like, I got to change this. And now, like, this Dunning-Kruger effect, I just learned about this a couple years ago. It would have helped me a lot prior to cope with the fact of what I have to do, how to get ready before I go to college. So the next thing that I want to talk to you about is this book that really changed my life. And this is where I'm talking to you about the social science. So this is a book called Stuck in the Shallow End. It's called Education, it talks about education, risk, and computing. It's written by Jay Margolis. Jay Margolis is also the author of Unlocking the Clubhouse. And that one focuses on the lack of women in computing. Both of those books I highly recommend for women, just to motivate you to realize the things that are happening, and let you see the things that are happening in your school, in your classroom, that are discriminatory against you. And it happens, you know, if you're a Latina and a woman, you know, you're getting both, right? And this happens for people who are low income. There's many more. This just talks about Latinas, so it really touched me. The other one talked about women. And so basically she was comparing this to what used to be the Jim Crow era, where you basically had schools segregated, you know, schools for Blacks and schools for whites in the area. So she looks at underrepresentation in CS as a contemporary window into how inequality is reproduced. And I 100% agree, because I see it happening all the time. And this is why it's so important to get computer science into all schools, in the public education system in particular. So she basically, in this book, she basically said she read this she talked about how the social history of swimming, she talked about how this book that she heard of and read gave her an idea as to why like Latinos weren't in the AP classes. Like they were literally nowhere, right? And women either. And he couldn't understand why it was. And so she heard an alarming statistic about how Blacks children were dying 3 times at the rate higher from drowning than white children. And so this book looks at the lack of access to pools, because in the Jim Crow era, basically only the white people had the country clubs and could go there and swim. African Americans could work there, but they couldn't swim there. And this is where what they did for swimming in the inner cities and the poor. And if you look at it, this is where it's stuck in the shallow end, because how in the world, if you can stand and hold on to the bars, and you have all these people in this little area, how in the world are you going to learn to swim? So it explains a lot of the stuff that goes on. And one of the things that is really interesting is that myths in the Black community happen. So I have very good super educated African-American friends, work in high places like the White House. Some of them work in, at institutions and talk about intercultural communication. And both of them said to me, I don't swim because Black people can't swim. And I'm looking at them with an awe, because I come from Colombia, where the whole coast is Black. And they're actually the best swimmers in Colombia. And I was like, wait, that doesn't fly. That's not true. And so, many people believe that maybe those myths were created. Who knows who that was created, if it's a mechanism to protect, by the parents to protect the children, or it may be as a mechanism to keep people out of the pools, right? So that they would only go to these regions. But there's this profound belief in that in the United States by African Americans. So then at the end, they look at Beverly Hills. So Beverly Hills is in Los Angeles, because the studies happened at 3 schools in Los Angeles. They look at the number of pools per household in Beverly Hills. And basically there's 1 pool for every household in Beverly Hills, which is the richest, wealthiest, most white community in Los Angeles, versus Boyle Heights, which is more a Latino community. There's only 1 pool for every 10,000 households. And so as I look at this, I think of my students, right? We have 3 million people still struggling with access for internet, right? And I wonder how many, in my community, in my students have computers at their house, right? So if we compare computers in Beverly Hills, what do you think with how many computers are there versus how many there are in Boyle Heights? And it really does become a question of access, and access not only to computers, but also to high quality education. So in computing, if you read the book, she actually, let me go back. If you read the book, she actually compares 3 schools in 3 different neighborhoods, 1 from a poor school, 1 from a magnet school that is majority minority, and 1 from a white public school in a wealthy neighborhood. And you'll see the difference. The white school basically had a full curriculum for computer science. The other one had the computers, but not the content. And finally, the poor one had had what we call the just the computers, and basically like internet processing, word processing and connection to the internet, like how to use a computer, basically. So then the other thing that happened while I was going through became a professor, I actually went to a thing called Grace Hopper. And at Grace Hopper, I got interviewed with like 100 other women for when women stopped coding. They were trying to figure out why in 1984, all these women, because that's actually at the beginning of computing, a lot of women were involved. They were actually leaders in this. And so here I have on the right, this is Bletchley Park, right? Bletchley Park, which is where they solved the ENIAC problem. The Enigma, right? They decrypt Enigma. Most of the people that worked as what they were called computers were women. And they basically, what they did was take messages and try and figure out, and through these communication with these women, they actually figured out what to do, because some of them could predict when certain things were coming out. And so once they had that prediction, then they could actually calculate how to decode it. And so the ENIAC women here were the first women who actually built a computer, and you don't hear about them. So women have become basically invisible. In the middle here is Joan Murray, formerly Joan Clark, and she was basically key in getting Alan Turing to be able to work with his colleagues. And that was something, people talk about Turing being so, he was brilliant, but he was also very arrogant and had trouble, working with his fellow colleagues. And if it had not been for Joan Clark, that might not have happened. And I keep thinking, maybe if we had more women, maybe it would have happened even sooner, right? So women were key in this development. And then I started, I always thought Grace Hopper, she might have been just some, they just made her up because, I had this in my mind that women were not good in computing, right? It turns out that she was actually critical to she created the first compiler. So before compilers, everything was like you put in the binary code by hand, and with cards and punch cards, and I this was transformative. And she created the first languages that used compilers. And then again, Barbara Liskov, she invented object-oriented programming, and it was really interesting because Grace Hopper started in computing at 38, so she was a big inspiration for me. But what's really interesting, and she was really good at math. She was a math professor. So what's really interesting to me is that the more I study women in computing, they're the ones that are focused on trying to make it more accessible for people, making it reach more people, and particularly work in languages, which is interesting because I love languages too. So here's some of the work that is happening here. Then I started thinking about women in science because, I've always heard about Marie Curie, but she's never mentioned as one of the greatest scientists in the world. But yet she's the only one to have ever received, she's the first woman to have ever received Nobel. But then on top of it, she's the only one to have ever received 2 Nobel Prizes in 2 different scientific fields. And there's only one other who won 2 Nobel Prizes in science. There are 3 others that have won in science and maybe the Peace Prize. So it's, when people say that women are not good in science, Marie Curie, if you read about her story, she didn't have access to a college education until she was in her late 20s. Early 20s, mid 20s, 24. And she actually, what she did was work as an au pair, teach herself while she could give her sister college. And then her sister, once she got finished and got married, brought Marie to France. And she wasn't always at the best universities, but she ended up working her way up. But then I also think about the discrimination to women, because when I read about her, they actually didn't give her the best, they gave her kind of, here, have this lab. And it was one of the worst labs. And I think to myself, she died of radiation at 42. How much, this stuff in academia and women really needs to change. And also I think about her daughter also won in chemistry and a Nobel Prize in chemistry. So people who tell me that, it's men are better than women, I think part of the reason Marie doesn't get named as one of the greatest is because it defies this idea of what a great scientist is. I mean, she, the whole field of radioactivity is still so prevalent right now in the world. Like the impact that made in the world right now is incredible. Then I started thinking, well, maybe it's only white women. And so when I saw Hidden Figures, it was amazing for me. And I thought to myself, there's got to be, I couldn't explain more. And so if you haven't seen the movie Hidden Figures, that they had at IBM, they had a whole section of women doing math that were women of color. And they basically were the first ones to start working with computers. And then also, Katherine Johnson was the one who did, the math by hand to help take the satellites, right? there's just so much that we don't know about women in computing. All these women have done incredible work. One of these was also in charge of this satellite, and I can't see my notes, so I can't remember. I just remember Katherine Johnson. She just got recognized like the year before she died, just recently. Anyway, so I say all this because in Puerto Rico, we just had the first Puerto Rican professional development of this course called Exploring Computer Science, which is one of the courses that I really recommend because it focuses on getting an idea of and passion for like 7th, 8th, 9th grade, 10th grade, just to get people into computer science, and you can tailor it to your community. And so we did the first all Puerto Rican professional development, which was a big deal because we had to translate it into Spanish. There's very few resources for this in Spanish. And I show you this picture on the side because I think that what is really cool about our first Puerto Rican, it's like Puerto Ricans teaching Puerto Ricans about how, to include equity, which is one of the things that we do, how to include, computational thinking, how to include all that in all our courses from K through 12, right? And we did the first one. And this is kind of like over here, breaking myths about what we can and can't do. And that's, I think, the most important thing that we have to do. We have to not let others define us, but define ourselves. And we need to become users, not just users, but creators of computing. And it all starts with computational thinking and statistical thinking for the research. So thank you very much. And I'd like to thank these people for helping me along the way. Rafael Lizarri helped me a lot to get the information. Carlos Alcenmi at NOAA helped me get the pictures and the story straight in terms of the story. And then, of course, Sonia and Ram for the invitation. Thank you.
Thank you, Patricia. You covered a lot of things, starting from data science 101 to Puerto Rico, that hurricane death story, to inclusion. And I'm so glad that you are co-chairing ACM's Inclusion and Diversity Council.
It's now called the Diversity, Equity, and Inclusion Council.
Okay, diversity. Okay, is this a new
We
council?
just changed it, so it's not even. But the importance of the word equity can't be underestimated in computing, and we hope that we can have an effect on that.
There are some questions here and there at the YouTube. So Kuku Mukherjee asked, in the school level, how can we make use of data science and give them an idea of utilizing in problems around them?
At the school level, what is that? Is that elementary school?
Or mid-level.
Yeah. Or yeah, okay. So in those cases for that, you just basically expose them to good research, like tell them these stories, like what I just told you, and they can do things in terms of. I do think it takes a while because they have to have the math, so it has to be a little bit higher level if you really want to expose them to the idea. But you can show them what a good article looks like, and show them, hey, this is an article that has good science because it has like references and you can find references. So this is all part of science in general. It's not specific to data science, but and expose them to articles of, things, concepts, like, for example, that we can make an analysis on a whole bunch of data, right? But that'll give us, averages for, it can make the results skewed. So talking about, bias in results, I think would be an important way to just show them, hey, look at what happened with this. And I do that now with my beginners. I always show them, hey, let's start with this to motivate why you need to be in data science.
Maybe that is related to the next. It's not clear it's a question or a comment. It says, Yogita Tango says, data collection may not give the solution statement always.
Correct. And actually, that's a very good thing, because So I think one of the really interesting things in medicine that I work with is like there's a conflict between big data in medicine and personalized medicine, right? So exposing them to that, personalized medicine says everyone reacts differently. Big data can give us trends, right? And meaningful information that we might not realize ourselves. So just getting them to realize that, you can extract information from data that gives you trends that you might not normally see. I think that's a great thing. But realize that it's not. So for example, telling them that it's a confidence interval. A lot of people think that you give 95% confidence. That means that 95% chance that you're going to, that nothing's going to happen to you. And I say this with vaccines, right? In particular, they say, 95% of the people don't have any problem. But it could be that you're somebody that will have 100% problem, right? So you really need, this is where the personalization of medicine comes in. So the 95 is the confidence interval based on analysis. So if they get that under, that's statistical thinking.
Sounds like the weather, Indian weather forecast sometimes has this sort of confidence interval with some errors and so on.
That's great. So you can start explaining that to them in the forecast. We don't get those. That's really good.
So one comment I had, so there's all this digging deeper on the death count reminds me of some of the controversies surrounding COVID deaths. Have you seen this, or has this been applied to? Because in many parts of the country, I'm sure maybe even in the world, people don't necessarily believe the numbers coming out of how many people have died in COVID. And one has to dig deeper, exactly or very similar to the way this team went about. Have you seen any such thing? And COVID?
Yeah, we actually did a datathon focused on COVID, and we presented this like the original creator. Rafael Irizarry was a keynote, and the idea there was to try and get people to figure out the percentage through a datathon. And so, yes, people are doing that to try and do that. And I think this is exactly the kind of confidence that you have to do, the kind of analysis that you have to do. So much so that he actually created a package in R to calculate this so that it makes it a little bit easier. So you could go to his website and find that package.
Okay, are there any more questions or comments? I see some attendees raised hand, but I don't know whether that's a mistake, or can you put your questions in the chat?
Venkatesh, may I make a comment while you are
waiting?
Yeah,
please go ahead. Yeah.
So I think, as I said, it's more a comment than a question, but I think your presentation I see as underlining the importance of learning environments being equitable as well. And I think, as teachers, very often we forget that, it's not only the discipline, or it's not only the disciplinary material content that is important, but the learning environment being equitable in every way. And invariably, post facto, when the role models, like people like you come and say, okay, this is uncomfortable, invariably it's post facto that the realization comes. So what are the things we should do, maybe from school level onwards, that so that our learning environments are more sensitive and equitable? I mean, it's not the same thing, but I mean, I would like to hear more of your thoughts on these.
So some of the things that I recommend is, for example, and I'm thinking like in computation, I'm assuming you're saying this for computation, right? So a lot of what I do is like pair programming, in the sense where, you have one person navigating and another one person driving, so that they build the collaboration. But then after like 20 minutes, they have to switch. Because a lot of times when you're a woman in computing, what ends up happening is that all the guys get together and they do everything, and then they give you like what's left over, right? So by doing pair programming, it's only two people, and you get one person working, and then they switch. And so it starts to build that respect between the two people by saying, hey, it's not just about me learning, but it's about you learning too, right? So I love pair programming. And I found that it's been very effective with my students. In data science, I really focus on a thing called POJL, which is process-oriented guided inquiry-based learning. So I do inquiry-based learning where I give them, and they don't like it at first. So I will just tell you that. They don't like it because I give them a question and I give them a problem and I give them a data set and I said, you have to solve it. But I give them roles in their group and I never make a group bigger than 4. So it's 3 or 4 in a group, because if you get too big, that's what ends up happening. One group does it and the other doesn't stay. So I think 3 or 4 keeps them all engaged, especially if you give each of them roles. And so the idea is that they all have to do those different roles so that, for example, one person isn't always a note taker, one person isn't always the spokesperson of the group, and one person is actually looking at how we're interacting and analyzing that. So that's a lot of what POJL does. So I've really, and I focus on collaboration a lot in the classroom. So it's not just content. It's actually learning how to work together. And that's, I think that's key. I think that's a big, important thing.
Okay, there's a question from Sarabjit Basin. How to connect middle school students with data science at their level to make them understand to find solutions of complex problems.
So one of the things that I, like I said, with middle school, I think you can start with smaller things. And just like, you know, having them read articles, because they don't have the math yet to do the statistics. Maybe some of them do, but that would be unusual. But they can definitely start thinking about statistics. So maybe like showing them a Jupyter notebook so that they can see what you can do. So like one of the things that I do with my class is do, there's this, the bias training. I don't know if you've heard about the COMPAS data set. COMPAS data set. It's an article published by ProPublica that shows the inequities. And that might even be too much for middle school because it's kind of, I always worry, am I doing, you know, at that age, they're so sensitive, they're still growing and they're still, you know, I don't know if I want to do that at that age because I've tried it with my nieces and nephews and then they start telling me like, so the world is grim and it's never gonna, like, so I worry about giving them social justice so little because they still believe that everything's, I don't know. But if you can give them something like in science, like incorporate it into science some way, where they're analyzing water samples or they're reading articles to try and figure out which ones are fake and which ones are not. I think that's the way to deal with middle school. Yeah, it's a hard time to know when to start to put social justice and maybe that is, you know, I haven't really decided. If you have very sensitive students, it can be depressing a little.
Okay, so I think there are no other questions or comments. So really, thank you very much, Patricia, for a wonderful talk, and it's covered a lot of things. Thank you, all the audience, and that actually brings the curtains to today's session on CTiS 2021. I'll see you all tomorrow at 3 o'clock Indian time. Okay, thank you very much.
Thank you so much for the invitation. It's been an honor. And yeah, keep, you're doing wonderful things. So thank you.
Hope to see you in person soon. Yeah, sometime.
Yes, that would be wonderful. Thank you so much, everyone.
Okay.
Thank you, Patricia.
Bye.
Okay. Have a great day. And
You
thank
too.
Yes, and thank you, everybody, and we shall see you tomorrow at 3 p.m.
Okay, bye for now.
Good.
Bye.
Shubha.
Good night.
Yeah, good night.